Yes, sir.
Thanks. Okay, so yeah, so I'll start from week 7, right? So basically we'll start with calculus. So the starting point is basically sequence, right? So can one of you tell me what is the definition of sequence? Any idea?
A series.
No, I'm asking about sequence. What is sequence? Anyone wants to give a try? Okay, so sequence is nothing but it's a function from the set of all. So yeah, so in this course we are mostly dealing with the real sequence. So sequence is a function from the set of all natural number. So let me also tell you this thing. So in the calculus part, when you are dealing with calculus, your natural number starts with 1, right? For the calculus part, okay. Okay, but for other, actually the natural number starts with 0. So sequence is nothing but it's a function from the set of all natural numbers to R. So that means what? You have F1, F2, F3, and so on, right? So you have bunch of list of numbers, A1, A2, A3, and this list goes on, right? This goes on till infinity. You have An, then you have An plus 1, and this list goes on. And here what we want to find, so we are interested to find the limit of a sequence, of course, if the limit exists. And what is the meaning of limit of a sequence? How you find the limit of a sequence? What is the main idea to find the limit of a sequence? Have you studied all these things, or like you have not started?
No, sir, we have not started. At least I have not started.
Okay.
Yes,
So
sir.
when is your exam?
Yeah, the same. 30th of this month.
Okay. Yeah.
Actually, we need your help to understand these things.
Okay. Okay, I guess, yeah. So you should start as soon as possible, because 30th means it's yeah, you need to read a lot, because if you don't know sequence, then of course even it will take a lot of time to understand what is differentiation and all these things. So it's better if you start as soon as possible. Okay, so yeah, so again, like the thing is, I can't go each and every details. That is the problem. So the sequence, what we want to find, we want to find the limit of a sequence. So what basically limit of a sequence means? Of course, if the limit exists. So limit of a sequence, when I can say that limit of this sequence, okay, so this is a sequence. When I can say that the limit of this sequence limit of the sequence is, let's say, A. So when I can say this thing, if you increase the value of n, okay, if you increase the value of n, then the terms of the sequence will come closer and closer to A, right? If I keep increasing the value of this n, I have n plus 1, n plus 2, and so on, right? This list is going towards infinity. Okay. If I increase the value of this n, if all the numbers of the sequence, okay, they are coming closer and closer to A, then I say that the limit of the sequence is A. Okay. But the thing is, I may not have any such number, right? If I don't have any such number A to which all the term of the sequence are actually coming closer and closer, in that case, I say that the limit of the sequence doesn't exist. Okay. And when the limit of the sequence exists, in that case, I say that sequence is a convergent sequence. When the limit doesn't exist, in that case, I say the sequence is a divergent sequence. So let me start with let's say the easiest example. Let's consider a sequence. Okay, an is equal to the constant sequence. Let's say 1, right? An equal to n for all n in n, right? So that means I have all the terms of the sequence are basically 1. That means my a1 is 1, right? A2 is also 1, and so on, right? So all the terms of the sequence are 1. So if you can keep increasing the value of n, then basically all the terms of the sequence are approaching to 1, right? You don't have any other choice because all the terms of the sequence are 1. So this is an example of convergent sequence. So here the limit is 1, right? And next, let's take one more sequence. Okay. So 1 by n, right? So can one of you tell me what will be the limit of this sequence?
Sir, 0.
0. Why?
As n tends to infinity, 1 by n will tend to 0.
Yeah, will come closer and closer to 0, right? So
Yes,
if
sir.
I write the terms of the sequence, the first term is 1, then 1 by 2, then 1 by 3, then 1 by 4, and so on, right? So if I increase, then the nth term is 1 by n, 1, yeah. So the thing is, if I increase the value of n, then you can see this 1 by n will come closer and closer to 0. Certainly it will never, it will be never equals to 0, but it will come closer and closer, very, very close to 0 if you increase the value of n. Okay. So that's why the limit of this sequence is 0. So in that case, you write the limit of the sequence is 0, right? Okay. So these are the easy examples. Okay. So again, let me take one more thing. Minus 1 by n by n. What will be the limit of this sequence? Anyone?
Sir, it will oscillate between minus infinity or infinity for the positive terms, like even number.
See, what is a1? Minus 1.
Minus 1.
Minus 1, right? See, you just need to substitute 1 in place of n, right? So this is minus 1.
0.
What is a2? 1 by
2.
2, right? A3 is minus 1 by 3, right? A4 is 1 by 4.
Yes.
Right? So this is your number line, right? This is your number line, and this point is 0, right? So first you are getting minus 1, right? Then you are getting half, right? Then you are getting minus 1 by 3. Then you are getting 1 by 4.
It's coming closer to 0.
then you are getting minus 1 by 5, right? So if you keep increasing, okay, then as you can see in both the sides, it's basically coming closer and closer to 0, right?
Yes, sir.
So it's basically coming closer and closer to a fixed point, and that point is 0, right? So that's why limit of the sequence is again it's 0. Clear this one? Okay. Let's take one more example. So what is the limit of this sequence?
Sir, it's an oscillating sequence, 1 and minus 1.
Yeah,
Limit does
so
not exist. 1 and minus.
correct. So as you can see, if you change the value of n, it's basically going, it's not, if you increase the value of n, it's not going towards any fixed number. Okay, so you have minus 1, then you are getting 1, then you are getting minus 1, then you are getting 1, minus 1, 1. Okay, so if I increase the value of n, it's not coming into some fixed point. It's basically going in between 1 and minus 1. Okay, so it's oscillating in between 1 and minus 1. It's not coming, the terms of the sequence is not going towards a fixed number. Okay, so that's why the limit, so in this case the limit doesn't exist. Okay, so you can say that it's this limit so limit doesn't exist, and this is a divergent sequence. Okay, and yeah, so next you take this slightly it's not that obvious. What will be the limit of this sequence? Okay, so let me write it. So I can write this an.
Zero limit.
Yeah, limit is 0. Correct. So I am trying to rationalize this thing. Okay, in that case, what I will get? I will get n plus 1 minus n divided by so this is 1 by right. So I can rewrite my sequence of in this form, right? So as n tends to infinity, as you can see, the thing in the denominator, okay, it's actually going towards infinity, right? That means the whole thing, the 1 by that thing, will go towards 0. So the limit of this sequence is 0, right? So clear? This question is, any doubt so far? Okay, so the next thing is, so once you have limit, the next thing is limit of a sequence, the next thing is limit of a function, right? So So how you compute limit of a function? Suppose you have a function. Suppose you have a function, let's say R to R. And let's say A is a point in R. So what is the procedure of finding limit of this function at x equal to 1? X equal to A. How you compute the limit? So what you do, you first try to compute the left hand limit and the right hand limit, right? So how you compute left hand limit? Suppose you have a function. Suppose you have a function like this, and let's say this is your point A. So what you do, you try to compute the left hand limit. The left hand limit. And what does this left hand limit means? Okay, so this basically represent the left hand limit. Okay, this is the sign notation for left hand limit. So what you try to do for how you can get the left hand limit? What you do when you are approaching to this A from the left hand side, okay, when you are approaching to this point A from the left hand side, you check where this function is approaching. Okay, the main thing is you check where this function is function value is approaching. So if it is approaching to some point, let's say L of if it is approaching to this point, then you say the left hand limit is L of L. Okay. And the next thing what you need to do, you need to check the right hand limit. And the right hand limit is the idea is more or less same. Okay. So what you do, again, you try to come to this point from the right hand side of it. And you check where this function is approaching. Okay. If this function is approaching to some, let's say some point, L of R, then you say that this L of R is the right hand limit. Okay. And if the left hand limit and the right hand limit matches, okay, at this point A, if both left hand limit and right hand limit matches, then you say that, then you say limit of this function at A exist, right? So the procedure is you try to first you try to check the left hand limit, then you try to check the right hand limit. If both the things are same at that point, then you say that limit exists. Okay. If they don't match, in that case you say that limit doesn't exist. Okay. So let me take an example. So let's say f of x equal to modulus of x, right? What will be the graph of this function? Let's say we want to find the limit of this function at x equal to 0. Okay, at x equal to 0. We want to find limit of this function at x equal to 0. So what will be the graph of this function? Anyone? What will be the graph of this modulus function?
V shape.
Correct. Right. So this is 0. So since I want to find the limit of this function at x equal to 0, my first task is to find the left hand limit. Is the left hand limit of this function at 0, right? Okay, so as you can see, when you are coming to 0 from the left hand side, the value of the function is also coming towards 0, right? So that means the left hand limit is 0, right? And similarly, when you compute the right hand limit, and you basically get a same sort of answer. So when you are coming to 0 from the right hand side, right, the value of the function is again coming towards 0, right? So in that case, both the left hand limit, so this is your left hand limit, and this is your right hand limit, and turns out that both the limits are same, right? So the left hand limit and the right hand limit matches, right? They matches. That means limit of this function at x equal to 0 exists, and the limit is what? Limit extends to 0, f of x, and here f of x is modulus of is 0. Okay, so this is the limit of this function at x equal to 0, right? Yeah.
Sir,
Hmm.
when function is not defined at f of a, then in what limit is defined or not?
Yeah, it's depend on the function. In that case, also limit can be defined. Okay. So even if the function is not defined at a point, still I can talk about the limit of a function at that point. Okay. I can talk about the limit, but I can't talk about the continuity. Okay, so the next question you may make. Okay, so let's take the next one. Is the greatest integer function. Let's consider the greatest integer function in this domain. Let's say the function I have defined from 0, 3 to r, right? So if I try to draw the graph of this function, what is the value of this function at x equal to 0? What is f of 0?
0.
Yeah, 0. And what is f of 0.5?
Again 0.
0, right? So in this interval, this basically this will give you 0, right? So this is 0, right? So let's say this is 0, this is 1, and of course this point is not included, right? This one is not included, because at 1 it will give you 1, right? And again this will give you 1 till 2, right? And this point is again not included, because at 2 it will give you 2, right? And again this will go till 3, and the same logic at 3, this point is not included, because at 3 the value is 3, right? This is 1, this is 2, this is 3. So this graph will look like this. So now what I want, I am interested in finding the limit of this function at x equal to 2, right? I want to find the limit of this function at x equal to 2, right? So how should I start? First, what I need to do? I need to find the
Find the left hand side.
Left hand.
yes. I need to find the left hand limit, right? And can one of you tell me what will be the left hand limit for this function at x equal to 2?
1.
Correct.
1.
Yeah. So when you are coming to 2 from the left hand side, as you can see, the value of the function is precisely 1. So the left hand limit is 1, right? And what about the right hand limit?
2.
So this right hand limit is 2, right?
2.
So as you can see, the left hand limit and right hand limit, they are basically different, right? Correct or not? They are different. So in that case, I say that the limit doesn't exist, right? Since the left hand limit and right hand limit are different, the limit doesn't exist. Okay. Any doubt so far? Okay. So once you understand the limit, okay, so once you know the definition of limit, then continuity in some sense it comes free, right? And what is the definition of continuity? When you say that the limit when you say that a function, suppose you have a function from R to R, when you say that the function is continuous at a point A, suppose you have a function from R to R, when you say that f is continuous at any idea?
So roughly says when you draw the function of when you draw the graph of function without lifting pen.
Yeah, that is fine. That is a vague thing, right? I am asking about the precise definition.
Limit of function is equal
Both the limit exist.
Then both the limit exists, then you say that the function is the limit exists. Okay, then if so, but limit and
Function
continuity
Left
are
hand limit is equal to right.
Value of the function equal to limit.
correct. So in that case only you say that the function is continuous at that point. So when you say that the function is, when your both left hand limit, sorry, this right hand limit is same as the left hand limit, and this is same as the value of the function at that point. Okay. So in that case, you say that this function is continuous, right? So if I go back and see this function, so do you think this function is continuous at R2?
No.
Right? Because the first of all, the limit doesn't exist, right? So the limit doesn't exist. So to talk about continuity, first of all, the limit of this function at that point should exist. Okay. If limit doesn't exist, then automatically I can say that this function is not continuous, right? Because these two things should match, right? And if both the things match, then I will go and check whether both the things are equals to this f of a or not. So in this case, this left hand limit and right hand limit, they are not same. Okay. So from there itself, I can say that this function is not continuous at x equal to 2, and there is nothing special. Even you can show that the function is not continuous at 1 actually. Okay. So what about this function? So whether this function is continuous at x equal to 2, x equal to 0?
Yes.
Yes, sir.
Because the limit is 0, right? And this is same as what? F of 0, right? So the limit of the function is basically same as the value of the function at that point. So that's why this function is continuous at that point. Okay, so let me consider one more function. So this is, let's say, this is my function. Right? This is the function. It's a piecewise function. And I want to talk about the limit of, I want to check whether this function is continuous at 0 or not. Okay. So again, to talk about the continuity, what I need to do, I need to first start with the left hand limit, right? So what I'm doing in left hand limit, I'm coming to 0 from the left hand side, right? So in the left hand side, what is the value of x? In the left hand side of 0, what is x? X is positive or negative? Negative, right? So if it is negative, that means if x is negative, what is modulus of x? Modulus of x is what? Minus x, right? So limit x tends to 0 negative, x square by minus of x. And this is nothing but limit x tends to 0 negative. This is minus of x, okay, and which is again 0, right? So if similarly, if I try to compute the right hand limit, so this is again nothing but limit x tends to 0 plus x square by mod x. So here 0 plus means I'm coming to 0 from the right hand side. That means here x is greater than 0. In that case, mod of x is nothing but it's x. So if you do the simplification, then what you will get? 0 plus. So here you will get x, which is again 0. So the left hand limit and right hand limit, they match, right? And they match, and also both the limits are same as f of 0, right? Because f of 0 is given there, it's 0, right? So that means whatever I have written here, this function, this is continuous at x equal to 0, right? Okay. So any doubt? Okay. So the next thing.
One thing.
Hmm.
What will be the video number in the video lectures for this,
Which one?
for the limit?
I don't remember the video number. I remember week wise.
Because I have gone through it just. I
Huh.
can't find it.
Yeah, it's there. Early. You can just simply you can
Week 7, right?
Yeah, week 7.
Okay, sir, I'll search it again.
Yeah. Okay, so fine. There is I guess there is one playlist for calculus. You can directly search in YouTube. Okay, any other thing, any other example you want me to discuss regarding this continuity? Okay, so let's then okay, let me check. Is there any other question I should discuss?
Fraction part function, sir.
So let's take this function. So the question is whether this function is continuous at x equal to 1 or not. how you are going to check it? How you are going to check it whether this function is continuous at x equal to 1?
Left hand side.
Yes, what is the left hand limit?
Less than 1.
Sorry?
1/6.
Correct. Because if x is less than 1, then the value of the function is constant, right? So it doesn't matter if you are coming to this one from the left hand side, then the value of the function is nothing but it's basically 1/6. So this is 1/6. What about the right hand limit?
The same thing, 1/6.
So for that, what I need to do, I need to compute limit on 1 plus x by x plus 1, because if x is greater than 1, then this is the value of the function. Yes, okay. Right. So in that case, as you can see, when x is coming to 1, this is actually going to 1, and this whole thing is going towards 6, right? So eventually the whole thing is going towards 1/6. So the left hand limit and right hand limit, they match, and also the value of the left hand limit and right hand limit, this is same as f of 1, right? So in that case, you say that this function is continuous at x equal to 1. Right? Okay. So the next thing is, once you understand continuity, so the next thing is differentiability. Okay. So again, how you check differentiability? Any idea how you should check differentiability? Anyone?
Firstly, function should be continuous.
Yes. Then
Then, sorry, sir.
what is the definition of differentiability? Okay, so suppose you have a function and you say that f is differentiable at x equal to a if this limit exists. Limit s tends to 0 so this is a, if this limit exists, then you say that your function is differentiable at x equal to 1. So if the limit doesn't exist, then the function is not differentiable at x equal to 1, right? So for example, you take this function f of x equal to x square, and what do we want to check? So we want to check whether this function is differentiable at a equal to 1. Okay. Whether this function is differentiable at this point or not, at 1. So for that, what I need to do, I need to check this limit. Limit s tends to 0, f of 1 plus s minus f of 1 divided by h, right? And this limit s tends to 0. What is f of 1 plus s? What is f of 1 plus h?
1 plus h का whole square.
Correct. So this is 1 square plus h square plus 2h minus f of 1, right? This is 1. So what you will get in the numerator finally?
H square plus 2h. 2 point h.
So we can now cancel, right? The h thing.
Yeah.
So this is nothing but
2.
2, right? So finally, what is the limit? Final limit, what? 2,
2.
right? So we are getting a limit, right? So that means this function is differentiable at a equal to 2, and the value of the function, the derivative of the function at this point x equal to 1 is 2, right? So f dash of 1 is 2. So since we are computing the derivative of this function, this is nothing but this is the derivative of the function at 1. Okay. So this value is 2, right? So this is a differentiable function. So it doesn't matter. So it's so instead of x square, if you take x cube, x5, or any polynomial, you can also show that any polynomial is a differentiable function. Okay. So but again, so certainly not all the functions are differentiable. For example, if I take this function, you have already seen this function f of x equal to mod x, and let's check whether this function is differentiable at equal to 0 or not. Okay, so we should check whether this is differentiable at this point or not. So then what we need to do, we need to find the limit, right? We need to check whether this limit exists or not. So a is 0, that means 0 plus h minus f of 0 divided by h. So what I will get in the numerator?
H minus v.
Right? So this is in the numerator, I'll get mod of h. In the denominator, I'll get h. Right? So now what I have, I have a modulus sign here. So I need to split this, right? So to compute the limit, again, I have to come back to the left-hand limit and the right-hand limit, right? So again, the same argument, 0. So when I'm coming to 0 from the left-hand side, my h is negative, right? So when h is negative, the modulus of h is minus h, right? So in that case, minus of minus h is basically minus 1. And when I'm coming to 0 from the right-hand side, the value of h is positive. In that case, modulus of h is h, right? So what you will get, h by h, which is 1, right? So as you can see, the left-hand derivative and the right-hand derivative, they don't match. So that means this limit doesn't exist, right? So that's why this function modulus of x is not differentiable at x equal to 0. So again, like the idea is same. Even if you graphically, if you can say that this function is not differentiable, because if you draw the graph, so the graph of modulus of x is actually looks like this. Okay, so the problem is here is this point. It's a corner point, right? So you can say it's a V shape. So you have a corner point. So since at 0 you have a corner point, so that's why from there itself you can say that this function is not differentiable. Whereas if you see the graph of x square, it's sort of smooth, right? So if you draw the graph of x square, so as you can see, there is no corner point. Okay, you don't have a shape, V shape like this. Okay, it's really smooth. So that's why this function x square is differentiable. Okay, whereas this function modulus of x is not differentiable. And similarly, if you take the graph of sine x, so if you draw the graph of sine x, then probably it will go like this, right? So again, it's, as you can see, this graph is smooth, right? You don't have any corner point. So this function is also differentiable. And same argument works for f of x equal to cos x as well. So cos x is also a differentiable function. Okay. So the difficult task is when you have some kind of piecewise function. So in that case, you have to be careful when you are trying to find the left-hand derivative and the right. And the next question is why actually we are computing this derivative. Okay, well, what this derivative, if a function is differentiable at a point A, then what this f dash f will give you. Okay, so suppose you have a function which is differentiable at a point, what this f dash of A will give. Any idea?
The rate of change.
Rate of change of what? Yeah, that is the derivative. Yeah, f dash of A basically gives you the derivative. Yeah, rate of change something. But again, like this has some other notion as well, right? So if this is your function and this is A, then f dash of A will give you the slope of this line, the tangent. So if you draw a tangent at this point A comma f of A, then slope of this line f dash of, right? Do you agree or not? That is the main idea, right? So that's why we are actually computing the derivative, because if the derivative is basically it will give you the slope, okay, the slope of a function at that so sorry, the derivative will give you the slope of the tangent at that point, right? And once you know that the slope is f dash of A, right, and the slope of this line, whatever this line is L, the slope of this line is f dash of A, and the line passes through A comma f of A. Okay, now can you compute the equation of the line? Now can you compute the equation of the line? Can one of you compute and tell me what will be the equation of this line here? So one thing I know, that slope of this line is f dash of A, and I know that this line L passes through A comma f of A. So what will be the equation of the line L?
Y minus f of A
Y minus f of A
is equal to f dash A into x minus A.
correct. So for example, if I take a function, sorry, let's say x cube plus 5x plus 1, and what I want to compute the tangent equation of the tangent to this function f of x at x equal to 2, right? So for that, what I need to do, first I need to find this f dash of A, and I need to find this A comma f of A, right? So what is this a comma f of a here? 2 comma f of 2, right? What is f of 2? 8 plus 10, 18. Sorry, 2 times 2 times 2, 8 plus 10, 18 plus 1, 90, right? And what is f dash of x? F dash of x is nothing but 3x square plus 5. And f dash of 2 is nothing but 3 times 4, 12 plus 5, it's 17. So the equation of the line will be y minus 19 is equals to 17 times x minus. So this line, whatever this line is, this basically represent the tangent line to this function at x equal to 2. Okay. Clear? Any doubt so far? Okay. Yeah. So yeah. So the next thing is basically I want to discuss about this local maxima and minima. And one of the reason of computing this derivative is basically it will give you a local minima or local maximum. So for example, suppose I have a graph like this. So yesterday you have seen the turning points, right? So suppose I have a graph like this. So as you can see in this part, this function is first increasing and then decreasing, right? So this in sort of in this part you can say this is the maximum value, right? And if I draw the tangent at this point, this tangent is what? This line is parallel to x-axis, right? That means the slope of this line is 0, right? So if this is my point A, which is of course a point of maxima, then f dash of A is 0. And similarly, if you see this point, and as you can see in this region, this point is the lowest, is basically giving you the lowest value, right? In some small neighborhood. So if I consider the tangent at this point, again this is parallel to x-axis. So this f dash of A is 0, right? So one of the way of finding this local maxima and minima is basically first you start with finding the turning points. So or turning points, or more generally you can say the critical points. Okay. So what is critical point? So a point A critical point of f of x if what are the condition it needs to follow?
Derivative changes the sign.
No. The first thing is, okay, it's not fasting. So either the function is not differentiable at that point, or the derivative is, the derivative is 0. Or the derivative is 0. In that case, you say that A is a critical point. Okay, and once you find the critical point, then you need to apply the second derivative test to find out which of the critical point is a local maxima or local minima. Okay, so the next thing is you need to apply the second derivative test. Second derivative test to find out the local maxima or minimum. So what the second derivative test says, if a is a critical point, and f double dash of a is greater than 0, then a is a local minimum. And again, if f double dash of a is less than 0, then you say that a is a local maximum. And if f double dash of a is equals to 0, then you can't conclude anything. Okay, that means that the test basically, the test can't give you anything. Okay, it's inconclusive. You can't get anything out of this function. So suppose you consider this point is considered a function f of x equal to, let's say, x cube minus 4x square. So what we need to do, we need to find the first, we are trying to find the local maxima and minima. So first what we need to do, we need to find the critical points, right? So for the critical points, we need to find all the points, because this, of course, this function is differentiable everywhere. So we need to find all the points at which the derivative of the function is 0, right? What is f dash of x here? Hello?
Square minus 8x.
Zero, right? So we want to find, so basically we want to find all the points at which the derivative is 0. So if this is 0, that means x times 3x minus 8 is 0. That means x is 0. And 8/3. Okay. So now I want to check whether this point is a local maxima or minima, or whether I am able to conclude anything or not. Okay. So for that, what I need to do, I need to compute the second derivative. What is the second derivative? Second derivative is what? It's 6x minus 8, right? And if I substitute 0, what I'm getting? I'm getting minus 8, right? And this is less than 0, right? That means 0 is a local maximum. Okay, because that is what it says, right? If f dash of a is less than 0, then my a is a local maximum. And next, if I compute f of 8/3, what I'm getting? 6 times 8/3 minus 8, which is of course greater than 0. That means 8/3 is a local mean. Okay. So this is the traditional way of computing local maxima and minima of a function. And how you compute? You basically compute by using the second derivative test. Okay, so it doesn't matter what your function is. Again, like it's sometimes it can be also difficult, but yeah, but whatever function you will see in this course, they're more or less easy, and you can apply this test to find out the local maxima and minima. Okay. Any doubts so far?
No, sir.
Okay. So again, like, is there any point, like so if you have not studied anything, I don't see any point of going of revising all these things, because I'm not getting any response from any of you. Occasionally someone is responding, and also you don't have any questions as well. So yeah, of course I'm feeling like I'm teaching to myself. Okay. So okay, so the next thing, okay, the next thing probably I'm not going into much of integration, so I'm just I'll discuss mostly about this integration by parts. Okay, how you can compute integration by parts. So at least, yeah, so this you should be able to tell how you compute integration by parts. Suppose you have a function like this. How you are going to, what is the integration by parts? Rule for this function? Hello?
Don't know, sir.
Okay, I guess, okay, so there is no point of continuing like this. Okay. So maybe, yeah, you study something, and maybe later we can arrange some session, because it's, at least it's completely boring for me. Okay, I don't know about you, because whatever I am asking, you don't know. Okay, so, and in this way also you can't learn anything. So you first study something, because I'm saying a lot of things. It's not sort of, if you don't know anything, then it's pointless. So even for you. So I'll suggest, yeah, you study something, then probably if you request, then we can arrange session for you. Because yeah, so as you can see, it's basically I am only saying some. So yeah, so you better you study, maybe later we'll take some session. Okay, so okay, let me just finish this one, then probably I'll stop. Okay, so yeah. So what I'm trying to do, I'm actually trying to integrate function using integration by parts. Okay, so let me write in this form. Okay, instead of writing that. So you know that this is this integration, even if I remove the limits, so this integration is nothing but fg minus f dash g, right? So this is how you apply this integration by parts, right? So so if suppose, okay, so let me take an example. Suppose I want to integrate x ex, right? So if this is my function, then how I'm going to choose which is f and which is g, right? That is also crucial, right? And how you do that? You apply this eyelet rule.
Eyelet rule.
Yes. So eyelet rule means what? This where what this I represent? It's inverse.
Logarithmic.
No, inverse trigonometry. And L basically represents, so inverse trigonometric function means you have function like this: sin inverse of x, cos inverse of x, tan inverse of x, right? And what this L represent is logarithmic function. For example, ln of x, or maybe ln of 2x, ln of maybe x minus x square. So the function that comes with log, that is basically this L represent this, and the A represent the algebraic function. That means function like x square plus 7x, and sort of function is more or less the polynomial function, let's say. And T represent
Trigonometric.
function. So function like sin x, cos x, tan x, right? And what is the last one?
Exponential.
Exponential function. So it's, yeah, ex, or maybe some 3x, 7x, function like this. So how you are going to choose f? Choose f. Choose f based on which of this comes first, right? So you try to check. So this is my x, right? And this is my ex, right? So x represent this algebra, right? And what is this e of x represent?
Exponential.
Exponential function, right?
Yes, sir.
Yeah. So e represent, yeah. So e represent exponential function. Okay. So then what will be the choice for f? What is
X.
what is the choice for f? F is basically
X.
f of x is x, right? And
Yes.
what will be the g of x? Okay, I made a mistake here.
Yes, sir. There will be f dash, and
So
that will be g.
it should be g. Okay.
Yes.
Yeah. So since x come before, so in this list, x comes before e of x. So choose g of x to be x and f of x to be e of x, right? So now if I apply this thing, then see, if you compute what is f dash of x is e of x. And what is g of x? G of x is what?
X.
X, right? So if I apply this whole thing, then what I will get? X e power x dx is nothing but what? So this is basically what? This is f dash of x, right? So what I will get? F times g, right? What is that? X times e power x, right? Minus integration of what?
X.
E power x derivative of g, right? What is derivative of g? Derivative of g is g dash of x is 1,
1.
right? And again, this is t of x. So, and further, if you simplify, what you will get? X e power x minus
EX. E power
ex. So again, this is nothing but e power x times x
x
minus
minus 1.
1, right? So this is the so yeah, so this is basically integration y part. Okay, so let me take one more example. So x cos x, let's say take x cos x dx, right? So again, if I follow the lists, what is a suitable candidate for g of x? What I choose g, basically, which appears first in this list, right?
X.
Correct. G of x is x and f of x is
Cos
f of x. Okay, so because since I have written I have written in this form, right? F dash g, right? F dash g, right? So if g of x is x, then I should search for a function f such that f dash of that function is cos of x, right? So in that case, f of x is sine of x. So here actually, okay, here I made a mistake. Here why? Because it's actually it's not creating any problem, because here f of x and f dash of x, they are same. Okay, that's why it didn't create any problem. But see what I'm writing. I am writing in this form, right? F dash times g. So if this is my g, then this should be my f dash, right? And if f dash of x is sin x, then f of x is f dash of x is cos x, then f of x should be sin x, right? Okay, so if I apply again, if I apply the rule, f dash of g is fg minus fg dash, right? So if I apply, what I will get? I'll get x sin x minus sin x. Sorry, not sin x. Is it sin x? Oh,
Will
no.
be sin x.
Yeah. So what will be the final answer? X sin x?
Sin x plus cos x.
Correct. So this is again this should comes with this. Okay, so the crucial part is okay, but this choosing f and g. So for that, it's better to remember this word I let because otherwise what you need to do, sometimes you may end up with the wrong choice. Okay, so for that you may have to do it twice. Okay, so that is not good in the exam point of view, because it can take some extra time. Okay, so it's always better to know this eyelet route. Okay, any doubt?
Sir,
Hmm.
sir, actually limit, sequence, derivatives and integrals, these topics are not covered in the video lectures. So from where we can get the video lectures of these topics?
Give me a minute. Just give me a minute. Let me check it. See, as far as I know, some of you don't have this calculus part in your syllabus, and some of you have. Okay, so yeah.
Sir, these topics are given in the syllabus. The PDF provided for the syllabus, it's in the syllabus. But in the video lectures, these topics are not covered. Limit and sequence, derivatives and integrals.
Yeah, just give me a minute. I'll just send you the playlist. So I shared a playlist. Okay, you check that playlist. So this thing basically starts with some things that from week 1 to 6, and then Sarang sir actually he started with the sequence. Sequence, continuity, differentiability, everything is there. Integration, everything is there. You can check. Is there, right? Have you checked?
Yes, sir.
Yeah. Okay. Okay, any doubts so far?
No, sir.
No, sir.
Sir, I am. Hello, sir. Sir,
Yeah, please. What is your doubt?
sir, I have applied for programming, sir. Deployment. In that, we don't have a calculus and something, but in mock question paper, there will be there is a calculus. Which is there is a calculus is in our subject or not, sir? In our syllabus or not, sir?
As far as I know, I don't know which one. As far as I know, one of you don't have calculus. Okay.
Sir?
One of this. There are two things, right? Diploma and programming, right?
Diploma in programming and diploma in data science.
Yeah, one of them don't have calculus. Okay. I don't remember which one. Okay. Because, yeah.
Is this enough for studying only syllabus?
Yeah. If see the calculus is not there in this in your syllabus, then why you need to study
Okay,
that?
sir.
Yeah.
Okay, sir. Thank you, sir.
Okay. Anything else? Okay, so let me start quickly again, go through the graph theory content. So, yeah, I guess okay, of course, I don't think you have studied graph theory as well. So, let me start with coloring. So, yeah. So what is graph coloring? Okay. So graph. Okay. So mostly so by this word graph, you can easily think what is graph. So graph is basically means you have bunch of vertices and bunch of edges. Okay, so see this graph always comes with two things, bunch of vertices and bunch of edges, right? So yeah, so if I suppose take this graph, let's say this is 1, 2, 3, 4, and if I draw this graph, then as you can see for this graph, these are the vertices, right? This 1, 2, 3, 4, 1, 2, 3, 4. These are the vertices. And what are the edges? Edges are this 1, 2, because yeah, 1, 2, 2, 3, and 1, 4. I have 4 edges. Sorry, 3 edges. So this is a typical example of undirected graph, because I don't have any direction. So I can go 1 to 4 as well as I can come from 4 to 1. Okay. So this is a example of, because I don't have any direction, right? On directed. Undirected graph. Okay. But I can have a graph with some direction. Okay. So I'm not explicitly writing the okay, let me write. So this is one is, and let's say this is one is, this is one is. So 1, 2, 3, 4. So this is the arrow, right? See this arrow basically gives you the direction. So see, this arrow is towards this node 2. Okay. So that means I can come from 1 to 2. Okay, but I cannot go from 2 to 1. Okay, I can come from 3. I can go from 3 to 2. Okay, but I cannot come from 2 to 3. I can go from 1 to 4. Okay, but I cannot come from 4 to 1. So this is a typical example of directed. Okay, so we have sort of two types of graph. One is directed and one is undirected, and you have further classification of directed and undirected graph. So before that, let me start with graph coloring. Okay, so what basically graph coloring means? So graph coloring means if you have a graph, you want to color the nodes of the graph so that node to adjacent vertices will have same color. And the question and the thing is, the main object of graph coloring is so you need to find the minimum possible color through which you can do the graph coloring. So for example, if I have a graph like this, suppose I have a graph like this, suppose I assign some color this to blue, right? See, if this is blue, I cannot, since these two vertices are adjacent, I cannot give the same color here. Okay, I have to give some different color. I give red here. Okay, and also I can, so here also I cannot give blue. I give, let's say, some other color, let's say green. Okay, so this is also a graph coloring, but what we want to use the minimum possible color. Okay, we don't want to use some as many color I want. Okay, so as you can see, this color is not necessary here, right? This extra color is not necessary. I can simply use red color, right? So I can simply use red color. So if I ask you what is the minimum coloring for this graph, then the answer is 2, because I just need to use 2 color, right? So suppose let's say I have a graph like this. Okay, so I should draw it properly. It's still bad. So in this case, I want to find how many minimum. So what is the minimum color required for this to color this graph? Okay. So any guesses? Any guesses?
3.
3. Any other guess? Okay, so
2
let's
is enough, sir.
sorry.
2 is enough, sir.
Okay, let's see. Okay, so the main idea how you should solve this question, you should always try to use as less color as possible. Okay, so you should always be, when you are coloring, you should check whether you can use a color that you have already used. Okay, that is the whole idea. So let's start with this one. This is red. Okay, so if this is red, then I can't give this one to be red, right? So I have to give some other color. Let's say I'm giving yellow. Now, can I give red color to this node? Can I give red color to this node? I can give, because see, this node is basically, it's adjacent to this one, right? And this is yellow color. Okay, but this node is not adjacent to this color. Okay, so I can give this one red color, right? And I can assign this one to yellow color, because see, this is yellow and the adjacent vertices, this is red, this is red. So they're different color. They don't have same color, right? So So I can give this one to yellow color. And I can give this one to red color, because see, this vertices is adjacent to this one, and this one. As you can see, this is red, they are different color. Okay, so it's not a problem. So as you can see, I just have to use two color to color this graph. Okay, so the minimum coloring of the graph is 2. Okay. So the answer is 2. So it's really, it's a easy concept. You just need to do it carefully. Okay, that's all. So so the next thing is vertex cover. So anyone know what is vertex cover?
No, sir.
So suppose you have a graph. Okay, so graph means you have bunch of vertices, okay, and bunch of edges. So vertex cover is basically it's a subset of vertices, okay, such that every edge in the graph, okay, so vertex cover is a subset of the set of vertices, such that every edge, okay, every edge in the graph, listen carefully, every edge in the graph should contain one vertex from the vertex cover. Okay, and the minimum set, sorry, what I want to say, so so you vertex cover is the minimum possible subset, okay, minimum possible subset of B, such that if I pick any edge from the graph, okay, it should contain a vertex from the vertex cover. So let me try to explain this with an example. Okay, so let's say you have a graph like this, V2, V0, V1, V5, V4, V3, right? So see, if I pick this set V0 and V1, V2, then this is a vertex cover. See why? Because if I pick any vertices, any edge from this graph, if I pick any edge, suppose if I pick this edge, okay, so this edge contain a vertices from this vertex cover, right? V0, it basically contains two vertices, it's fine. So if I pick this one, it contains these vertices, right? V0. If I pick this edge, then it contains V2. If I pick this edge, then it contains V2. If I pick this edge, this edge contains V2. So this vertex cover is not unique. So instead of this, I can pick one more vertex cover. This is V2, V1, right? This is also this can be also a vertex cover. The same argument. If I pick this edge, okay, this edge contains one vertex from the vertex cover, right? This is V2. If I pick this edge also contains one vertex from the vertex cover, that is V1. And same rule applies here. Okay. So for let me take one more example. Suppose if I take this graph, V0, V1, V2, V3. What is the vertex cover? For this graph, what will be the
VO
vertex?
and V3.
See, you have to take the minimum possible thing. Okay, so that is, see, if I take V0,
V0 is enough.
V0 is enough, right? If I pick this vertex, then it's clearly this, sorry, if I pick this S, then clearly this S has V0 and we have V0 here. Same applies for this S, same applies for this, right? So, but if I add one more, let's say this one, okay, then this V0 is not, V0 is not a vertex cover, right? I have to add one more thing. So I can add V0, V1, right? This is a vertex cover, or you can take V0, V2, right? This is also a vertex cover. Okay.
Okay, sir.
Yeah. So, yeah, so the last thing what I want to discuss, which is, okay, so it's basically what? Minimum cost spanning tree. So what is that? I'll explain what is that. So,
Sir,
yes.
after this, can you explain me the polynomial function and linear function and non-linear?
Sorry, I didn't understand your question at all.
Can you explain me the polynomial function, linear and non-linear?
What is, yeah, linear? No, you are
After
asking
this.
about, no, that is fine. What you are asking, definition or what?
Definitions, sir, definitions.
What is polynomial function? Okay, before going into the thing, okay, tell me what is, so if you have a function which is basically of this form, right? A n xn an minus 1 xn minus 1 and a0, right? So this is, so if a n is not equal to 0, then this is a polynomial of degree n, right? So for example, if I consider this function, let's say 5x7 2x square x minus 9. So as you can see, this is a polynomial, right, of degree 7, right?
Oh,
and
okay, sir.
linear function is what? Linear function is basically, it's a polynomial of degree 1, right? If I consider this polynomial f of x, which is x plus 1, right? This is a polynomial, right, of degree 1, right? So that's why this is a polynomial of degree 1, and that's why this is a linear function. Okay. So non-linear function is slightly different. Okay. So it's depend on the teacher, what basically, because there are lot of non-linear functions. So I should not say, so it's depend on the teacher. I don't think in our course sir has defined non-linear function. Okay.
Okay, sir. Thank you, sir.
Yeah. Okay, so yeah. So what I want, so the next thing is I want to find minimum cost. Spanning tree. Okay. So what is tree? Tree is basically, it's a connected acyclic graph. It's a acyclic graph. Sorry, it's a connected graph which don't have any cycle. Okay, cycle means you have something like this. Okay, or you have something like this. So if you start from here, you can again reach to this point. Okay, using this path. Okay, so tree is a connected graph which don't have such type of cycle. Okay, so what do we want? We want to find the minimum cost spanning tree for a weighted graph. Okay, so for example, if I have a graph like this, let's say I have a graph like this. Again, see, the problem is that you have not studied all these things. So 3, 1, 0. So suppose this is a graph, and so here there is one extra thing along with the graph. So here the graph, they have some weight for all the edges, some weight. 20. So what I want here, I want to find the minimum cost spanning tree. Okay, and to get this minimum, please mute yourself. For the minimum cost spanning tree, okay, there are two algorithms. One is Prim's algorithm. And one is Kruskal's algorithm. Okay, so I'll basically discuss only one algorithm. You can check the other one. Okay, so let me discuss this Prim's algorithm. You can apply actually any of the algorithm to get the answer. Okay, but again, like I feel this one is in some sense, in terms of complexity, I guess this one is slightly better. Okay, but yeah, so for this course, I don't see much difference. You can apply any another. So in Kruskal's algorithm, to find this minimum cost spanning tree in Prim's algorithm, what you do? You choose the edge which has the minimum weight. Okay. So in this graph, which edge has minimum weight?
1, 2.
This one, right? Next, you check the adjacent edges of this edge. Okay, so what are the adjacent edge of this edge? This is the adjacent edge, right? This is the adjacent edge. This is the adjacent edge. This is also an adjacent edge, right? So next, what we can do? We have to choose the minimum edge weight. Okay, of this edge, okay, which are minimum among all the edges which are adjacent to this edge. Okay, so which one is the minimum?
10.
0, 10.
10, right? And again, now what you check all the edges which are adjacent to this as well as this, and we have to check the minimum among them. So which one is minimum? Minimum is 18, right?
18.
But the problem is I cannot select 18, because if I select 18, okay, it will give me a cycle, right? Because I have already chosen this one. I have already chosen this one. So I can't choose 18. It will give me a cycle. Okay. So then since I cannot choose 18, then I have to go to the next minimum, okay, which is 20.
20.
So now what is the next choice? What is the next choice? I can't select 18. Now I have 8 and 17, right?
8.
Then of course I have to choose 8, right? So as you can see, now actually we got a minimum cost spanning tree of this graph. So because as you can see, this is, so what we got. If you draw this graph, this is what we got. Okay, so this is actually a spanning tree. This is a spanning tree, right? And the way we have chosen this spanning tree, so basically we have applied this Prim's algorithm. This spanning tree will have minimum cost. Okay, so this is the idea of this Prim's algorithm, and the Kruskal's algorithm also more or less have the same idea. Okay, so instead of looking at the adjacent edges, you have to choose the minimum weight in the whole graph. Okay, first you choose the minimum, then you go to the second minimum, then you go to the third minimum in case of Kruskal algorithm. And in this process, you should not create any cycle. Okay, you should not create any cycle. Okay, so that is the whole idea of this Kruskal algorithm. And Sprint's algorithm, that is, as I said, okay, you check first you pick the minimum widget, then you check the adjacent edges of that edge, and you pick the minimum one, and you keep on going. Okay, and you have to make sure that you are not creating any cycles. Okay, any doubt?
No, sir.
Okay, fine. Okay, so yeah, so this is what I have planned to discuss. So if you don't have any doubt, then probably I'll stop the session.
Sir, will there be any more sessions?
I don't know. If you want more session, then probably you can write to the support team. Okay. Well, I don't have any problem of taking session later, because if you write, then probably you can take. Okay. If you need further sessions, okay, just write to this course support.
Okay, sir.
Okay. Because yeah, so anyway, maybe yeah. So the thing is, we'll have session for this end term. Okay, for the end term, for the semester students. Okay, so this basically have the same syllabus. Okay, but there yeah, so then probably we can send the link of this session to you people, then you can attend. So probably we'll have 3 more revision session for the semester. I'll talk with the team.
Okay, sir. Thank you.
Okay, yeah, thanks.
Thank you, sir.